We are going to review some concepts for the SAT. So, exponent properties. First thing you remember, if the exponent is negative, you put it under a 1. So this would be 1 over x to the 1/3 power. I don't know why I wrote the negative down there. It shouldn't be there. So that's equal to 5 over 2. When you have the 1/3 power, that's the same as taking the cube root of x to the first power. So 1 over the cube root of x equals 5 over 2. What we can do is we can cube both sides. That'll get rid of the cube root. So 1 cubed is 1, cube root of x cubed is x, 5 cubed is 125, and 2 cubed is 8. Now you could simply just take the reciprocal of both sides, just flip it over. 1 over x would be x over 1, which is just x, and you got 8 over 125. So x equals 8 over 125. Another thing you can do, like in the green when it was 1 over cube root of x to the third, you could flip it right there. Just make it cube root of x over 1, which is cube root of x, equals 2 over 5, and then cube both sides. And you'll get the same answer. So here, you got the 4 and the 8 as bases. We're going to get it to the same base. So 2 squared is 4. 2 to the third is 8. And then we'll bring in the other exponents. 2n plus 3. Now, they both have the same base, the 2. So we don't even need the 2's anymore. That don't matter. But we're going to take those exponents and multiply them. So if we distribute the 2 here, we'd have 4 n plus 6 equals, and then distribute the 3n plus 15. Oh no. That's supposed to be 15. Oh dear. N plus 6 equals 15. Oh my goodness, I'm so embarrassed. Subtract the 6, n equals, it'll say -1, but it's supposed to be 15 minus 6, which is 9. Oh my goodness, I'm so embarrassed. Alright, 5 to the x over 25 to the yth equals 125. So again, we're going to turn these all into base 5, right? So 5 is 5 to the first. 25 is 5 to the second power. Okay, I guess I'm going to make the marker smaller here. 5 to the x over 5 squared. That's getting raised to the yth power. And then 125 is 5 to the third power. So if we multiply the exponents, we'd have 2y in the denominator. And then remember, when you're dividing, you're subtracting the exponents. So it's going to be 5 to the x minus 2y equals 5 to the third. And then again, once we have it down to just the bases, we can get rid of the bases, the 5's, because we're solving the exponents. So x minus 2y equals 3, but we're trying to get solve for x. So get x alone, so we'll have to add the 2y's to the other side. X equals 2y plus 3. Alright, number 4. This is going to be like a substitution problem. So a to the x is equal to b, so we can substitute that in for b in the next equation. So it's a to the x raised to the y power equals c. So c would equal a to the xy. And then we can do substitution with that. In the third equation, we could substitute in for c. So it would say a to the ax, or a to the xy raised to the z power equals a, which is a to the first. So then if we multiply the exponents, it'd be a to the xyz equals a to the first. Now they're both with the base a, so we can just solve the exponents. Xyz equals 1. That is cute. hey, why not try number 5? Now, a and b are positive integers, so you want it to be the largest thing possible. So if you distribute the b to both of those, it'd be negative 2 to the b power and a to the b power. Here, it'd be negative 2 to the 2b power. So it would automatically make it positive because it's to an even exponent. Then you'd have a to the 2b power. Okay, on c it'd be 2 to the b, 2 to the b, and a to the b. So already that's smaller than option B. So that's out. And then you have 2 to the first. Well, obviously that's going to be smaller than negative 2 to the 2b power. So the a's are the same, but the negative 2 and the 2, the negative 2 is actually going to be bigger because it's going to turn to positive. So B is our best answer here. This is going to be another one of those substitution type problems. So if you look, we have y to the 9th in the equation on the right. That's 3 times, that's y to the 3rd cubed. So we can substitute that in. If we cube both sides of the first equation, we'd get x to the 6th is equal to y to the 9th. So if you know that x to the 6th equals y to the 9th, and x to the 3z equals y to the 9th, then we could set the x's equal to each other. Now we've got the same base, get rid of the x's. So we're just solving 6 equals 3 times z, divide by 3. 2 equals z. Yes, yes, yes. Oh, here we go. Square root of 9 is 3. So let's change it. We're going to want all these bases to be 3. So we have 3 to the negative 7th. Now the square root is the same as something to the 1/2 power. So the square root of 3 we're going to write as 3 to the 1/2, but that's all being raised to the negative 4th equals 3 to the k. So 3 to the negative 7th times, if we multiply the exponents here, it'd be negative 2. Now we have our property where we add the exponents. Negative 7 plus negative 2 is negative 9. 3 to the negative 9th equals 3 to the k. Get rid of those 3's. We're solving the exponents. Negative 9 equals k. And over here on number 8, we've got square roots isolated, so we're going to square both sides. Now, when there's a term outside, you have to square that as well. So 2 squared is 4, but then the square roots cancel. So it would just be regular x minus 2. 3 squared is 9. Square root of 2 squared is 2. So if we distribute the 4, we'd have 4x minus 8 equals 9 times 2 is 18. We'll add the 8 to both sides here. 4x equals 26. Divided by 4. And 26 divided by 4, if you reduce it, we'd have 13 over 2, which is 6 1/2, which as a decimal is 6.5. That's it for page number 1. Get excited for page number 2. Oh, yeah, I guess I'm checking it over here. Obviously, this is a voiceover later. That was probably a smart move to check it. So that would be 2 root 4.5 whenever that shows up. Oh boy, this is embarrassing. Oh, here we go. 2 root 4.5 equals 3 root 2. Now if you check those in a calculator, you end up with the same decimal. I forget what it is here. Let's see. Come on. Oh, here we go. Okay, it is still not there. I can't believe this. How much time is being wasted right now? Oh my gosh, this is the last minute of the video. For 4.24 equals 4.24, and obviously the decimal goes on forever.